Several questions on the assessment test usually involve the distributive law. We know that we have the following rule in mathematics. A times B plus C, in parentheses like that, is A times B plus A times C. We distribute the A times B plus A times C. Okay, now we can use the distributive law in this direction to multiply out an expression. And sometimes we have to do that and possibly simplify an expression afterwards. We will also be using the distributive law in the reverse direction for factoring. For example, you may have a question that asks you to multiply x times x plus 5, and they give you various possible answers. Okay, if you think of this as A times B plus C, it's A times B plus A times C. That is x times x plus x times 5. X times x plus x times 5. Of course, the answer would probably be written as x squared plus, instead of x times 5, 5x. Okay, we were using the distributive law to multiply this out. A common mistake with the distributive law is that people forget to distribute the x all the way through, so they write x squared plus 5 instead of x squared plus 5x. On the other hand, you might have a question that asks you to factor x squared plus 5x. And then what you do is you look to the left and the right of this plus sign to see what is the greatest common factor that these two terms have, the greatest thing that you can pull out in front. Okay? Well, the most that they have in common, this is really x times x, of course, and this is 5 times x. Okay, and what they have in common is an x. We can pull out the x, and then we see what we're left with. Well, to the left of the plus sign, if we take out one of the x's, we're left with an x. And to the right of the plus sign, if we take out an x, we'll be left with the 5. Okay, using the distributive law now in the reverse direction. Okay, of course we can check what we've just done, x squared plus 5x. If we multiply it out, we do get that. So we have factored it correctly. So we can use the distributive law either in this direction to multiply out, or in the reverse direction to factor. Let's try some more examples. One thing to remember, the assessment test is a multiple choice test. And therefore, if you're not 100% sure you have the right answer on the factoring, you could try multiplying out all the various choices to see if you do get the right answer. Okay? In other words, if this is a possible answer, you check it x squared plus 5x and you see it is correct. So if you sort of forget how to factor, you do have the possibility of just checking all the multiple choices that they give you for the factoring. Okay? We multiply out the following: 3x squared times x cubed minus 4x plus 2. Okay, we can extend the idea of the distributive law, say a times b plus c plus d. In other words, a times b plus a times c plus a times d. Okay, so it'll be 3x squared times x cubed minus 3x squared times 4x plus 3x squared times 2. 3x squared times x cubed minus 3x squared times 4x plus 3x squared times 2. Okay, this will give us 3 x squared times x cubed is x to the 5th power. They have the same base. You keep the base and you add the powers. Of course, x squared times x cubed would result in 5 of these x's in a row, so it's x to the 5th power. Minus, now 3 times 4, that's 12. X squared times x to the 1st power would give us x cubed, plus 3x squared times 2. 3 times 2, that's 6x squared. 3x to the 5th minus 12x cubed plus 6x squared. Alternately, you could have started with the final result, and they could have said 3x to the 5th minus 12x cubed plus 6x squared. Factor that, in which case you would look at each term and try to figure out the most that you could take out, the most that they have in common. Well, first you would look at the numbers, 3, 12, and 6. You're looking to pull out the biggest number that is a factor of each of these. And 3 is the best that you can do. 3 goes into 3, into 12, and into 6. Now we look at the x's. We have x to the 5th, x cubed, and x squared. The most that we could take out would be an x squared. But it's the lowest power, because you can't take out an x cubed because it's more than you have in this term. Having decided what you're going to take out, you now see what's left in each term. You have 3x squared times something will give you 3x to the 5th. And of course that something is x cubed, because this multiplied out gives you 3x to the 5th. Now, 3x squared times something has to give you minus 12x cubed. Well, the 3 times a minus 4 will give you the minus 12. X squared times an x will give you the x cubed. And then finally, what do you have to multiply 3x squared by to get 6x squared? And the answer is just 2. So we get that. Factoring, we get 3x squared times, in parentheses, x cubed minus 4x plus 2, which is, of course, what we started with. So be prepared for these questions to be asked in either form. Okay, let's try some more of these. Factor the following. 6x squared y cubed minus 8x y squared. Okay, now we're looking for the greatest common factor for these two terms. Okay, let's first look at the 6 and the 8. First take care of the constants, then the x's, and then the y's. Between the 6 and the 8, the most that we could pull out in front, the largest number that goes evenly into both of those is 2. 2 divides into 6 evenly, and 8. It's a factor of both 6 and 8. Now we look at the x's. We have an x squared and an x. The most that we can take out is x to the 1st power, since that's all that appears there. And then we have a y squared and a y cubed. The most that we can take out is a y squared. And let's see what that will leave us with. In the first term, we have 2xy squared taken out. What do we have to multiply that by to get 6x squared y cubed? Well, to go from 2 to 6, we'd have to multiply by 3. To go from x to x squared, we'd have to multiply by x. And to go from y squared to y cubed, we'd have to multiply by y. If we multiply this out, we get 6x squared y cubed. Now, to go from 2xy squared to minus 8xy squared, we'd have to multiply by minus 4. That would give us minus 8xy squared, and that would check out. Always, when you finish factoring, use your distributive law to multiply it out again and see that you get what you started with. Okay, let's try to factor this now. 15 p cubed, q to the 4th, plus 25 p squared q to the fifth. First we look at the 15 and the 25. The largest common factor for 15 and 25 would be 5. We look at the p cubed and the p squared. The most that we could take out from both of them would be the smaller of the two powers, that is p squared. Q to the fourth and q to the fifth, the most that we could take out would be q to the fourth. And let's see what we're left with. What do we have to multiply 5p squared q to the fourth by to get 15p cubed q to the fourth? Well, to go from 5 to 15, we have to multiply by 3. To go from p squared to p cubed, we need a p. To go from q to the fourth to q to the fourth, we just need a 1. So just 3p is missing here to get the 15 p cubed q to the fourth. Now, what's missing to get 25p squared q to the fifth? Well, we have a 5. We have to multiply by 5 to get the 25. We have the p squared that we need, so we don't have to mess with the p. From q to the fourth to q to the fifth, we have to multiply by q. So, we have factored it out. It's 5p squared q to the fourth times 3p plus 5q. Another popular question on the assessment test looks something like this. 6a squared plus 8a over 2a. There are two ways that you can do this problem. One way is to try to factor the numerator. Look for the greatest common factor and pull it out in the numerator. Now, 6a squared and 8a. As far as the 6 and the 8 goes, the most they have in common is the 2. As far as the a squared and the a, the most you can take out is an a. And let's collect, see what's left over. To go from 2a to 6a squared, from 2 to 6 you'd have to multiply by a 3. To go from a to a squared, you'd have to multiply by an a. Similarly, if you have a 2a out, what do you have to multiply by to get 8a? Just a 4. So we have factored the numerator, 6a squared plus 8a, into 2a times 3a plus 4, and we can check 6a squared plus 8a. At this stage, we can, of course, cancel the 2a's, divide numerator and denominator by 2a, and get a final answer of 3a plus 4. This is one way to do it. Another way is to make use of the fact when you have a bunch of terms in the numerator over a common denominator, you can break them up and put each term in the numerator over the same denominator. That is, a plus b over c is a over c plus b over c. You can only break up numerators in this fashion, not denominators. Okay, so another way of handling this problem is to write it as 6a squared plus 8a over 2a. And to break it up, this is a plus b over c. Write it as a over c plus b over c. So 6a squared over 2a plus 8a over 2a. Okay? And in this first term here, the 2 equals into the 6, we divided numerator and denominator by 2, and we got 3 here. The numerator and denominator can be divided here by an a, which will make this just 3a in this term, plus here the a's cancel. We divide numerator and denominator by a, and again we divide numerator and denominator by 2 and get just 4. So we do get, of course, the same answer that we had over there. I want to point out the wrong way of doing this because the wrong answers always appear on the multiple choices, as one of the multiple choices. What you must never do, okay, if you have 6a squared plus 8a over 2a, okay, never say, just take the 2a, cancel it into the 8a and write just a 4 and write 6a squared plus 4. It's wrong. It's probably going to appear as one of the choices on the test. Okay, you just can't choose to cancel the 2a with the 8a here. Or another wrong way of doing it would be to cancel the 2a into the 6a squared and write this as 3a plus 8a. And then, in fact, some people might finish it off as 11a. So there are a lot of wrong ways of handling it. The most important thing is to remember that both terms have to be divided by the 2a. This we illustrated over here by factoring out the 2a and then canceling. Or if you want to break it up, fine, but break it up, put each term in the numerator of the same denominator. In other words, the 6a squared gets divided by the 2a, but so does the 8a. And the most common mistake is forgetting to divide each of the terms in the numerator by the 2a. So there are two acceptable ways of handling it. Okay, let's try another problem like this. They might ask you to simplify 10y squared minus 15y over 5y. Okay, one thing you could do is to factor out, take the greatest common factor on the top and then cancel, or to break it up and put each term in the numerator over the same denominator. We'll do it both ways. The first idea of looking for the greatest common factor on top between the 10 and the 15, the most we can take out is a 5. Between the y squared and the y, we can take out a y. And that would leave us with, what do we have to multiply 5y by to get 10y squared? That's 2y. That gives us the 10y squared. Now, take away, what do you have to multiply 5y by to get 15y? And the answer is 3. So then we could then divide numerator and denominator by 5y. So we get 2y minus 3 as our answer. Okay, the other possibility, 10y squared minus 15y over 5y. Break it up, put each term in the numerator over the same denominator. 10y squared over 5y. Take away 15y over 5y. 5 goes into 10 2 times, and you can also divide numerator and denominator by y, giving us 2y from the first term minus, here the y's cancel, and 5 goes into 15 3 times, so 2y minus 3. By the way, if you're not sure if you have the right answer, remember, in either case, what we have shown is that 10y squared minus 15y over 5y, okay, is 2y minus 3. We think that that's correct. Well, if it is correct, you should be able to multiply 5y times 2y minus 3 and get 10y squared minus 15y to check it. Okay, in other words, if 12 divided by 3 is 4, it is also true, cross-multiplying, that 3 times 4 is 12, and that's what we've done here. This is like the 12 divided by 3 equals 4. So 3 times 4 should be 12, if this is in fact the right answer. Okay, in other words, 5y times the 2y minus 3 should be equal to the 10y squared minus 15y. And of course, if you multiply it out, you do get 5 times 2, 10y squared minus 15y. So it works out. Okay, if you find this very difficult, remember there is this choice of actually checking each of the choices that they give you on the exam by multiplying it by, say, 5y and seeing which one gives you the correct answer. There are also questions on the assessment test involving square roots and right triangles. When you see the symbol square root of 9, what we mean is the positive square root of 9, which is plus 3. If we want the negative square root of 9, okay, it would have to be specified. If you just see a square root, we want the positive square root of 9, which is 3. Okay, the square root of 9, the positive square root of 9 is 3, since 3 times 3 is equal to 9. Similarly, the square root of 25, the positive square root of 25 is 5. We have certain rules for working with square roots. We have that the square root of a product is the product of the square roots of the factors. The square root of a, b is the square root of a times the square root of b. We're assuming, of course, that the numbers here are all positive numbers. Just rewrite that over here. The square root of AB is the square root of A times the square root of B. This can be useful if you want to simplify. For example, there may be a problem that asks you to figure out the square root of 6,400. Okay? 6,400 is, of course, 64 times 100. And we now know that we can write that as the square root of 64 times the square root of 100. Square root of 64 is 8. The square root of 100 is 10. And the answer is 80. Some people might know how to do that directly, but if you don't, you can do it by using this rule. Similarly, we have a rule for fractions. We assume the denominator is not 0, and the square root of a fraction is the square root of the numerator over the square root of the denominator. Sometimes this is helpful. For example, the square root of 16/25. It can be done directly, or you can say it's the square root of 16 over the square root of 25, and that is 4/5. However, these simple rules do not work for addition and subtraction. We have one for multiplication and one for division. However, remember that the square root of a sum is not equal to the sum of the square roots, and the square root of a difference is not equal to the difference in the square roots. For example, in a problem, if we're working out the square root of 9 plus 16, you cannot simply write this as the square root of 9 plus the square root of 16. That will be wrong. It would be nice, it would seem easy to do it that way, but it's not right. 16 and 9 is 25. The square root of 25 is 5. The square root of 9 we know is 3. The square root of 16 is 4. 3 plus 4 is 7, and 5 is simply not equal to 7. So it does not work out. If you have to work with the square root of 9 plus 16, you add them together first, and then you take the square root. You cannot break it up. It is true that it worked for multiplication. The square root of a product was the product of the square roots of the factors. The square root of a quotient was the square root of the top over the square root of the bottom. However, it does not work for addition and subtraction. And similarly, if you had the square root of 25 minus 9, this is not equal to the square root of 25 minus the square root of 9. You have to say 25 minus 9 is 16, and the square root of 16 is 4. That is the correct answer. If you do it this way, the square root of 25 is 5. The square root of 9 is 3, and we get 2, and that is incorrect. Okay, so in these problems, you simply add them together or subtract them and get the square root of the result. You cannot use this kind of a rule. It is important to keep these ideas of working with square roots in mind when dealing with right triangles. A right triangle is a triangle that has a 90-degree angle in it. Okay, a triangle like that. Let's say this is A, B, and C. The lengths of the three sides, we very often use a lowercase letter, for example, a little a, to indicate the length of the side opposite angle A, and a little b to indicate the length of the side opposite angle B, and a little c to indicate the length of the side opposite angle C. Since angle C is the right angle here, the side opposite the right angle is called the hypotenuse. Okay, we have in geometry a rule known as the Pythagorean Theorem, which says that in a right triangle, the sum of the squares of the two legs, these are the legs of the right triangle, is equal to the square of the hypotenuse. That is, a squared plus b squared equals c squared. The sum of the squares of the two legs, these two sides, is equal to the square of the hypotenuse. And very often on the assessment test, you're given a right triangle, and you're given 2 out of 3 of the A, B, and C, and asked to find the third quantity, whether it's one of the legs or the hypotenuse. And you'll have to use your work with square roots to do it. Let's try some examples. In the right triangle, and they give you 2 legs, 6 and 8, and they give you the third side is C. Find C. Okay, well, we have A, B, and C. We know that A squared plus B squared equals C squared. That is 6 squared plus 8 squared equals C squared. We have here 36 plus 64 is C squared. 100 is equal to C squared. And therefore C is the square root of 110. Okay? Theoretically, it could be plus or minus 10, but as the length of that side of the triangle, it's going to be plus 10. Let's try some more examples. In the right triangle, oh, by the way, we said it was a right triangle. Very often they put a little line there, lines here to indicate that that is the right angle. Okay, here we have 8b 17. In the right triangle, given there, find B. Okay, once again, A squared plus B squared equals C squared. 8 squared plus B squared is equal to 17 squared. 64 plus b squared is equal to 17 squared, which means 17 times 17. 7 times 7, 9. 4 and 7, 11. 17 times 1, after you've indented, 289. B squared is therefore 289 minus 64. I wanted to solve for b squared, so I subtract 64 from both sides of the equation. B squared is, now we need 289 minus 64, which is 225. And then b comes out to be the positive square root of 225, or 15. Okay, let's try another example. In the right triangle, find B. A squared plus B squared is equal to C squared. 5 squared plus B squared is equal to 13 squared. You can do the squaring now, or you can subtract. I just want to show you what happens. Let's say we subtract 5 squared from both sides. 13 squared minus 5 squared. What I'm trying to point out earlier was that you cannot say b is simply 13 minus 5. Okay? Or 8. You cannot take, for a difference, the square root of this minus the square root of that. 13 minus 5 would be 8, where in fact the right answer, 13 squared, comes out to be at 169. Multiply 13 by itself and you'll get 169 minus 25. B squared is 169 minus 25 is 144, from which we see that B is equal to 12. Since 12 times 12 is 144. So if you had just taken 13 minus 5 or 8, you would have had the wrong answer. In this case, B is equal to 12. And as our last problem on this videotape, let's try this. In the right triangle, we have here a 4, a 5, and let's call that C. Find C. Okay, now I know many of you have heard the expression a 3, 4, 5 right triangle, but that would have to mean, well, the hypotenuse is always the longest side in the triangle. So I'm sure on the exam one of the choices would be 3, but that happens to be incorrect. Okay, so just don't see 4 and 5 and assume that the other side is 3. It is clear that C is going to be the hypotenuse, the longest side in this triangle. So let's try it. A squared plus B squared is equal to C squared. 4 squared plus 5 squared is equal to C squared. 16 plus 25 is equal to C squared. 16 plus 25 comes out to be 41. 41 is equal to C squared, and C is the positive square root of 41 would be the answer. And as I said, don't be surprised if 3 is one of the choices. They're trying to trap you. You've heard of 3, 4, 5 right triangles, but this is not one of them. In a 3, 4, 5 right triangle, 5 is the hypotenuse. Okay, so in this case, the answer is C is the square root of 41, and that brings us to the end of this tape.